Hello guys, welcome back to my channel. Today, we're going to be looking at how we find the square root of a complex number. So let's start by having a simple complex number. Let's say we have a plus ib, and we want the square root of this complex number. Now we must assume that the square root of a complex number will also be a complex number. So we can say let the square root of a plus ib be equal to x plus iy, which is also complex. Now, since we have both complex numbers being equal, the concept that we use is that if two complex numbers are equal, the real parts are equal and imaginary parts are equal. In order for me to determine what the real and imaginary parts are, I first need to get rid of the square root. So we could go ahead and square both sides. So let me write this as x plus iy squared equal, when I square a square root, it's just going to cancel, so I'm going to have a plus ib. Okay, now x plus iy squared, this represents a perfect square, which means we can use a shortcut to expand this bracket. So we square the first term, which is going to be x squared. We multiply the first term by the second term by 2, so that's going to be 2xyi, and we square the second term. Now the second term is iy. Now when I square I, I'm going to get a negative 1. I squared is equal to negative 1. When I square y, I'm going to get y squared. So I'm going to have a negative y squared. And this is equal to a plus ib. The concept of the equality of complex numbers says that if two complex numbers are equal, the real parts are equal. So on the left, my real part is x squared minus y squared. And on the right, my real part is a. Likewise, my imaginary part on the left is 2xy, and on the right, it's equal to b. So what it means is that I'm going to have to solve this system of equations simultaneously to determine what x and y are. Then we can simply go back to the x plus iy and populate it. So this is the concept behind finding the square root of a complex number. And we're going to go right into looking at a simple example. Now here's an example. Find the square root of 5 plus 12i. Now, bear in mind that this is a complex number. We don't know what the square root is, so we're going to make an assumption here. So we're going to say, let the square root of 5 plus 12i equal x plus iy. Now, notice here, there are certain things that we need to say. One is that x and y are real numbers. They're members of a real number system. Now, if this is true, we can actually go ahead and say x plus iy squared would be equal to 5 plus 12i. What we simply did was to square both sides. Once we square the root 5 plus 12i, you know that the square root will go away. So once again, we did the expansion for this already. So we know it's going to be x squared plus 2xyi minus y squared equal 5 plus 12i. Now making this comparison, my real parts as we have it on the left here would be x squared minus y squared. This is going to be equal to 5. And my imaginary part is 2xy, which is going to be equal to 12. So we have two equations here. I'm going to call this equation 1. I'm going to call this equation 2. Now, based on how these equations are set up, there's only one method here that I can use, and that's by method of substitution. So we're going to go to equation 2 first. So let me say from equation 2, we could transpose to either x or y. Let me go for y. Y is equal to 12 over 2x, which implies that y would be equal to 6 over x. Now what we're going to do is to substitute this into equation 1. So we sub in equation 1 for y. What am I going to get? I'm going to have x squared minus, in the place of y, I'm going to have 6 over x all squared equal 5. So by laws of indices, once I square a fraction, I square the numerator and I square the denominator. So I'm going to have x squared minus 36 over x squared equal 5. All right, we need to get rid of the denominator so we can multiply everything by x squared. While as indices becomes x to the 4 minus 36 equal 5x squared. Right away we can see that this is a hidden quadratic equation. So I'm going to bring everything to one side. I'm going to have x squared minus 5x squared minus 36 equals 0. Now, since the coefficient, sorry, that would have been x to the 4. Since the coefficient of x to the 4 is 1, we can go right ahead and use the shortcut method. So we need two numbers. When we multiply them, we get minus 36, but when we add them, we get the negative 5. Now that would be a negative 9 and a positive 4. So when I factorize this, it's going to be x squared minus 9 into x squared plus 4 equals 0. Now, of course, concept, if two things multiply to give us 0, one must be 0. So it's either x squared minus 9 equals 0 or x squared plus 4 equals 0. In this case, x squared would be equal to 9, and over here, x squared would be equal to negative 4. Of course, x squared being equal to negative 4 is not applicable, because bear in mind we said that x and y represent real numbers, so that is out. That's going to be a complex number. Now, if x squared is equal to 9, this would imply that we take the square root of 9, which means that x would be equal to plus or minus 3. Bear in mind that initially we had, so we can recall, y equals 6 over x. So we can say when x equal 3, y equal 2. And when x equal negative 3, y equal minus 2. Good. So I can conclude that the square root of 5 plus 12i is equal to plus or minus 3 plus 2i. So here when we take the root, or when we find a square root of a complex number, it can either be positive or negative. And if we want to test these answers, all we need to is to take them, square them, and the result should be 12. 5 plus 12i. All right.